Okay, well, let's make a start. It's 5 o'clock here in the UK. So good morning to those of you on the West Coast. Good afternoon to those of you joining from the East Coast. And good evening to anyone joining us from Europe or stations further east. Thank you for joining this, the 22nd of our regular series of seminars on pumping topics. This one will last about 40 minutes, allowing us time for a Q&A session at the end of the presentation. So let me restart the screen share. Here is a listing of all the previous short courses we've run during the last year. If you've missed any of them, you can get a copy of the materials from our website. Use the following link, shortcourses.ruhrpumpen.com, or you can go to ruhrpumpen.com and follow the link to RP Short Courses. If you go to ruhrpumpen.com, you get to this screen, and here is the link to RP Short Courses. If you click on that, it takes you to this screen, which you can also access directly using this link here. And here you'll see all the courses listed, and you can click on any one of them to see the course material. So short course 1, short course 2, 3, 4, 5, 6, 7, 8, 9. Most of the 21 courses are up there. I think 18 at the last count. We don't like to put them up too soon after the live presentations, or people will not bother to attend and just download them, which spoils the value of the live Q&A session at the end, which is actually my favorite part of these sessions. Here's what we'll be covering today: a brief overview of the coking process in refineries, and an in-depth look at the hydraulic decoking process and equipment. As usual, we'll be holding a Q&A session at the end, so please use the Q&A facility at the bottom of your screen to ask any questions or make any suggestions and comments. I'll address those that I can live at the end of the session, and the rest we'll address by mail in the coming days. We're recording the session, and we'll make it available to all attendees as a YouTube link, as well as by emailing you a PDF version of the slideshow and the Q&A summary from both of today's sessions. So here is the agenda. After a brief review of the process, I'll touch on the various components of our decoking system, which sets us apart in the marketplace. Today, as you know, Ruhrpumpen maintains its world headquarters in Monterrey, in Mexico, with worldwide manufacturing and service centers. The Center of Excellence for Decoking Operations is in Witten, Germany. And that's this photograph here. Coking is actually one of the oldest refinery processes, and it was originally done with horizontal drums where they had an open flame underneath the drum, and the drum was a 55-gallon barrel. They'd cut it open and dig the coke out with a shovel or a pickaxe, and then they'd do it all over again. With the creation of the steam locomotive, they then turned the drums vertical and drastically increased their size. They'd put a chain or cable in the drum when filling, and then physically get into the drum to attach the cable to the locomotive. It would break, and they'd have to use dynamite and pickaxes. That is then when they advanced to the hydraulic coke cutting system that we see today. Flowserve were the first players in the hydraulic decoking game in 1938. They weren't called Flowserve then, of course, they were Worthington pumps. They had no competition until the year 2000, when Ruhrpumpen entered the game and invigorated the industry with improved and innovative designs. This fresh approach is what you'll be seeing in the coming slides. Delayed coking is the process consisting of heating residuum from the refining process to its thermal cracking temperature in a furnace with multiple passes. The cracking of the heavy, long-chain hydrocarbon molecules then turns the residuum into coker gas oil and petroleum coke. Then the process of hydraulic decoking is the removal of the petroleum coke from the coke drums by means of hydraulic, by which we mean water pressure. When you look at this last paragraph here, you can well understand the importance of coking and of hydraulic decoking to the refining industry. Here's a photograph of a coker, and you see a 4-drum coker. And here in these derricks up here, this is where most of the decoking equipment is installed, which we'll see in the coming slides. So this is the coking and decoking processes. So feedstock comes into the fractionator, the light ends come off, the naphtha, distillate, kerosene, LGO, MGO, they come off, and then the residuum enters the furnace where it's heated to coking temperature and fed to the coking drum. Large volumes of steam are injected after the furnace to delay the coking reaction until the flow makes it into the coke drum. That's where heavy oil is cracked to lighter hydrocarbons and into coke that mostly deposits in the drum for removal during the regeneration cycle. The cracked hydrocarbons then head to the fractionator column, back to the fractionator column, for separation of the separate streams, and with the bottoms product recycled back to the inlet for another pass through the coker. The process of hydraulic decoking is the removal of this petroleum coke from the coke drums by means of water pressure. Decoking is a batch process where after the drum full of coke is quenched, then it's ready for hydraulic removal. The decoking system provided by Ruhrpumpen consists of the jet pump, as well as the lifting gear to raise and lower a cutting tool. There's the cutting tool. The operator of such a system can be local, meaning at the cutting deck, or remote, meaning at grade or at ground level. Most newer systems are being controlled remotely for safety reasons, to get the personnel away from the deck. This slide is showing the trend over time of the size of the decoking drums. The red line at the top shows the flange to flange length of the drum, and it shows it how it has steadily increased over time. From in about 1930, when it was about 15 meters, to 2015 here, where the average was about 35 meters, sometimes as much as 40 meters, 45 meters. The blue line is the diameter, the drum diameter in meters. And again, this has gradually increased with time. Back in 1930, it was about 4 meters. And now today, it's around 10 meters. So the volume of coke has gone up considerably. Ruhrpumpen designed for a 6,000 psi system from the start, so it covers the full range of decoking parameters, and we designed for this increasing trend. Next couple of slides, I'm going to show you some reference lists, which They show not only, of course, how clever we are, but the main reason for showing them is to show the recent trend in cutting system type. In the early years, they were mainly hydraulic and manually operated systems. We saw an increase in electrical drives in the 2000s. And also, as we get into the 2010s, an increase in the remote, more of them going to remote and automatic control. Again, we see the same trend. And these are some systems that are in manufacture at the moment. The heart of the decoking system is the jet pump, which is often the largest pump in the refinery. It's a BB5 design according to API 610, so a double case barrel pump, with a cartridge design for easy changeouts, which is very important since this type of pump is often unspared and continuous operation is critical. So being able to change out the inner cartridge is critical. Now, many of you will have attended session number 8 of these short courses, where we looked in detail at the BB5 barrel pumps. If you need a reminder, you can download both the slideshow as a PDF and the video of the presentation from the Ruhrpumpen website. And here I'm just going to give a brief recap of the key features, particularly as they apply to decoking jet pumps. Here we see the outer case, the barrel, which may be a casting or might be more commonly a forging. It has top nozzle configuration most commonly, although it can be side or side top. The inner case here is a radially split diffuser type. The impellers may be inline or facing the same way, or as shown here, back to back. Here we see 3 facing one way and 3 facing the other. So the flow comes in here, in through the suction, into the first stage, out and into the second stage, out and into the third stage. Then it enters this crossover and comes back the other way into the 4th stage, into the 5th stage, into the 6th stage, and out the discharge. This slide shows ball type bearings. They can be hydrodynamic type, sleeve or tilting pad on larger pumps, and these would require a separate lube oil system. Now this is usually the case in decokers. They nearly always, because they're big, heavy pumps, some of the larger pumps that we manufacture, so they tend to have Kingsbury bearings, tilting pad bearings. Here is the balance line to equalize the seal chamber pressures, and it also acts as a drain line for the low pressure areas of the pump. Here is the non-drive end cover. If you release these bolts, you can pull out the inner assembly as a cartridge in this direction. Looking at the sectional drawing of it, here the drive end cover forging is separate from the case forging. So it means it's part of the inner cartridge, and this whole assembly, including the bearing housings and mechanical seals, can be pulled out this way, like this. And as we mentioned before, frequently these are not spared pumps. They run on their own continuously. And so easy change out of this pump cartridge assembly is essential if you're to keep continuous operation. Frequently there will be a spare cartridge in the warehouse, and you change it over in approximately one shift. This slide shows the typical indicative performance parameters of the pumps, of the jet pumps. The flow rates, head and speed can be quite high to meet the decoking requirements. Here is a typical decoking pump skid, which includes a 10-stage VB5 barrel pump, a gearbox, and a high voltage motor with all the lube oil piping. Here is a view of Ruhrpumpen's patented test lab to conduct the R&D and also string tests of complete unit tests of the pumps. We can test the jet pump, the motor, the lube oil system, the decoking control valve, which is up here, and the cutting tool. The cutting tool is installed in this blue framework here in horizontal position, so that when it's operating, you can see the jet of water through these windows. To properly conduct a complete unit test, it's important that the pump skid is on a massive permanent foundation rather than raised up on temporary supports. So here we see the lube oil assembly. It allows it to be installed in a sunken area of the test facility, which allows gravity flow of oil back to its reservoir. And it means because it's sunken and the main level is up here, as here, it means we're on a massive foundation and not elevated onto temporary supports, temporary stilt supports. And as I say, through these port windows in the blue section, you can see the jet water stream. The length of this section simulates up to a 30-foot diameter drum, so a 9-meter drum. Here we see the installation in the field. The pump is in here somewhere. Yeah, there it is. And this is the control panel. Looking now at the derrick on top of the drums. Here's the derrick. And we're looking now at the cutting tool, the cutting system. So the wire rope starts here at the hoist, goes up through a single pulley to the crown block double pulley, onto the traveling block double pulley, and then terminates back at the crown block. The crown block has a load cell which measures the wire rope tension. An absolute encoder is used to accurately measure the travel distance of the cutting system. Depending on the licensor, the wire rope can also terminate at the cutting deck location. You can see in this configuration on the left, the wire rope terminates at deck level, close to the hoist. Ruhrpumpen prefers the configuration on the right, which is typically called out by the Wood Group and McDermott as licensors. This version is preferred by Bechtel Hydrocarbon Technology Solutions. Here's a close-up view of the crown block pulley with its load cell and the absolute encoder. Ruhrpumpen utilizes robust 24-inch diameter sheaves or pulley wheels in its pulley blocks. And we can do revamps on any existing system. For revamp jobs, and where there is a customer preference, Ruhrpumpen can supply an I-beam, a common base plate, which makes installation of the pulley systems much more simple when they're on a base plate. One of the key safety features are the double catch bars shown here at the bottom of each blue-coloured pulley. And the purpose of these are to catch and safely hold the pulley and rope in the unlikely event that the pulley shaft should ever break. Here we see the pulley system with the cover removed. You can see that it's gear driven and drives this absolute encoder, which accurately records the position of the cutting head with no slip. It has sealed bearings and is maintenance free. We can adapt our crossheads and pulley systems to suit and replace existing installations. There are 3 different operating systems available. The electrical system is most commonly supplied these days. The hydraulically driven system, still quite popular, and the oldest pneumatic systems almost never supplied these days. Here is the hoist system, which is an established mining industry design. It can be driven by electric motor with a VFD, which is located remotely in a safe area, or it can be hydraulically driven. Here we see the wire rope. It has tension measurement via the load cell and transmitter, which avoids the slack rope and overloading, and it indicates at the main operator panel. The crosshead is installed and operates between 2 T-section rails. These are in grey-green here, with 4 guide points here, 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 and here. Each comprises 3 wheels, and we'll see those in the next slide. This is the drill stem drive, which is electrically motor driven. Here's the drill stem, which will rotate. The high pressure water comes in here through the gooseneck and down through the drill stem, down to the cutting tool. Free fall arresters here are built into the guide points. Here's a close-up of the guide wheel system. The T-rail here, which has been adopted from the elevator industry. And here are the 3 wheels, 3 guide wheels, which give accurate positive location and smooth operation. The free fall arrestor works on a broken wire rope. As soon as there is no upward pull force, this spring-loaded linkage rotates, and these cam mechanisms grip the T-rail and act as a brake, like this. Here are the cams and tungsten carbide grips here, here, and here grip the T-rail. Ruhrpumpen can do a field test during commissioning and recertify the free fall system at every turnaround or every several years. Now, this is an interesting design we've developed, the offset crosshead. Over years of heating and cooling, the coke drum frequently distorts in shape. It can become banana-shaped rather than perfectly cylindrical. The normal centralized crosshead would no longer be entering the coke drum centrally, as we show here in this middle photograph here. It's off to the side. With the offset design, we can correct for this banana shape by moving it in the east-west and north-south direction as necessary to counter the banana shape. Here again is the cutting system, which has a variable frequency driven electric motor, a high load bearing here, which is grease lubricated, cartridge packing, and here again is the water inlet. So here we see the exploded view, which is of 4 sub-assemblies. There's the casing and high pressure piping. There's the bearing and gear cartridge. Here is the electrical drive unit. And here is the seal cartridge. This center bull gear bearing is very similar to that used on a crane. Ruhrpumpen revolutionized the coke cutting equipment with innovation and safety by bringing in proven technologies from other industries and adapting them to coke cutting equipment, such as this center bull gear bearing, which from the crane industry, and the T-bar, T-rail from the elevator industry. So usually electrically driven, as shown here. Here in this sectional drawing, here's an example of a pneumatic motor. The seal cartridge and the gear cartridge as sub-assemblies can be easily removed at deck level. Automatic greasers for the drill stem drive, low maintenance, no oil bath. Now we can adapt our drill stem drive to suit and replace existing installations. Here we're looking at the latching mechanism, which holds this whole drive assembly in the parked position for maintenance. Here it is in the normal unlatched position. It's held in the retracted position by an internal spring. And when energized, the actuator pushes out the latching device into its weight-bearing position, like this. Retracted, engaged. The design of the drill stem has been an area of continuous improvement over the decades. The original designs had welded 6-inch Schedule 160 pipe sections. In the 1980s, API extreme line threaded pipe, 7-inch OD, 3/4-inch wall thickness came into play. And that is still the state of the art at the moment, although Ruhrpumpen has pushed the state of the art forward with the RPX premium system. In the RPX premium system, the wall thickness at the coupling is much thicker. See, it's 38 millimeters, 1.5 inches instead of 3/4 inches. The conventional API extreme line casing is shouldered only at one end, the external end. The internal end is not shouldered, and this means cutting water can get into the threads. The RPX Premium has a double shoulder, as well as being much thicker section, 38 millimeters instead of 19 millimeters, and with a superior V-shaped thread with radiused roots. Here's a side-by-side comparison of the two systems. the extreme line here on the right in green and the RPX premium in blue. And if you look down here, connection tensile yield over twice as strong, the RPX premium compared with the extreme line. We hold stocks of the pipe at our key service centers. This one is in Houston. Moving on now to the cutting tool. Ruhrpumpen has the slimmest tool on the market at 13 3/4 inches for 350 millimeters. What you're looking at here is the auto switch cartridge, which is above the cut nozzles and 90 degrees to the cut nozzles. Here are the cutting nozzles, here and here. And here at the bottom are the drilling nozzles. It auto switches between cutting modes, either in drilling mode, where pressurized water is directed to the bottom 4 nozzles, or cutting mode, when the water is directed to the 2 horizontal nozzles. The auto switch cartridge is bolt-in and replaceable on the deck, so that the cutting tool never has to leave the unit or be removed from the drill stem just to change the auto switch cartridge. It has a long, thin, heavy-duty lower cover with a protection plate. No oil bath, as it is completely driven and lubricated by the drilling water. So there's no maintenance, no having to change the oil regularly, and of course, no possibility of oil contamination. The auto switching cartridge operates on a very simple principle. The pin extends when cutting water pressure is applied and retracts when the cutting water pressure is removed. So it's switching between drilling mode and cutting mode. Drilling mode, cutting mode. The Ruhrpumpen nozzles are bolt-in and completely recessed. They can also be changed while the tool is still installed, and there's no need for a hot work permit to change them. In drilling mode, water is directed to the 4 bottom nozzles, 40% to the vertical central nozzle and 20% each to the 3 peripheral nozzles, which are at 15 degrees from the vertical. This creates a water pattern like a drill bit, which allows us to cut a straighter, faster pilot hole that results in fewer fines. Then, when the operator switches to the cutting mode, the flow is diverted 100% to these side nozzles, the 2 horizontal nozzles in the side of the cutting tool. So first you drill the pilot hole, then you pull the assembly to the top, switch over to cutting mode, and lower the assembly again while cutting coke with the horizontal nozzles. Any repairs or upgrades get tested in our test labs. We have test labs in Houston and in Witten in Germany. This drill stem centering device is bolted onto the T-rails to positively centralize the rotating drill stem. And this safety enclosure provides a safeguard for when the cutting tool is outside of the drum. It protects personnel from the possibility of drill water hitting them. It has a large hinged door to be able to access the cutting tool for maintenance. It also has a neat cutting tool carrier here in red, which takes the weight of the tool and swivels out for easy tool maintenance. Another critical part of the cutting installation is the main control valve. This is installed at ground level, adjacent to the jet pump, and is in the discharge piping of the pump. When the pump is running, which it does continuously, remember, this valve diverts the flow either to recirculation mode via the bypass line, which would be when no drilling or cutting is taking place, or it diverts it to the cutting tool via the main line when coke drilling or cutting is taking place. It's electrically actuated via a gearbox and cams. And you can see here, this is the bypass valve, and here is the main valve. They're synchronized such that as the main valve closes, the bypass valve simultaneously opens so that the pump can never be deadheaded. This is the view from the inlet side, and here the reverse view. It's a non-clogging design able to pass 5mm diameter coke fines. The licensor requirement is to be able to pass 3mm fines, so this design exceeds that. We supply the complete control system as part of the package. PLC panels, programmable logic controller panel, and VFD, variable frequency drive panel. Ideally, they're located in a safe area within 250 meters of the motors. But this isn't always possible, so here we see the VFD panels for the hoist and drill stem drive motors in stainless steel custom panels purged with instrument air. Here we see the pump control panel for the complete pump and lube system. And here the local control panel in an operator shelter installed up at the cutting deck level. And here's the outside view of a typical operator cabin. The operator can control the operation of the decoking control valve, the isolation valve, the hoist, and the drill stem drive, all via an interactive P&ID on the human machine interface, the HMI. But this is the preferred option these days, remote installation with a video monitoring system. This is for safety reasons. It gets personnel away from the deck. A few slides here to illustrate the interactive P&ID screens. Here's an overall system view. You see the 4 drums, and this is the one that is working. Here is the operational pump and its lube system. Here we see the operating pump, P123, operating, and it is in bypass mode. You can see here is the main control valve, and it's bypassing back to the suction tank, the clear water tank. Here is the help screen showing what each screen indication means. Here the drum undergoing decoking, although, as I said before, this is in bypass mode at the moment. And finally for today, 5 of my favorite holiday snaps of the decoking pumps we've supplied. I won't leave them up for long. You can look at them at your leisure when you get your hard copy of this, or your electronic copy of this presentation. Well, that pretty much concludes the fun for today. Here is where I get to advertise the next of the short courses, Pumps for the Desalination Market. Thursday, the 27th of April, that's in 4 weeks' time. And after that, we'll be looking at magnetic drive pumps and then cryogenic pumps. I'm leaving this meeting open for a little while to allow you to post in the Q&A box, and I'll endeavour to answer those that only need a short answer here and now. Those that need a fuller answer will be answered within a few days, either by me or by one of my colleagues. I do have to admit, I'm not a product expert in these, so it might well be that I can't answer your questions immediately, but it will be answered in the coming days. Our marketing team are standing by to direct your questions and suggestions to the best person to answer them, and they will send you the YouTube recording and the PDF of the presentation. If you need a certificate of completion for this short course, again, info@shortcourses.ruhrpumpen.com. And here right at the end, as usual, are 8 slides about Ruhrpumpen that remind you of who we are and what we do. They'll be in the PDF copy of the presentation you get, so you can peruse them at your leisure. So now it just leaves me to say, if I stop the share here, we can get on with the Q&A. And let's see if we have any questions. And we have a couple. And Stavros Skitsakis says, does Ruhrpumpen supply only complete systems, or do you also supply the cutting system with the jet pump being supplied by others? Well, we do retrofit. So if you've got, for example, an existing flow-serve system where the jet pump is still working absolutely fine, yeah, we'll just supply the cutting tools and the crosshead as needed. Klaus Graf says, does the RPX drill stem have a constant outside diameter? It's slightly wider at the coupling itself, and so it's flared a little bit. At the coupling itself, it's a bigger diameter than it is the rest of the 10-foot section. Pruthviraj Davale, excuse me if I pronounced it wrongly. Instead of decoking valve, we can use an ARC valve. It works. No, you do need the decoking valve. An ARC valve wouldn't do the job. What we're looking for is to be able to gradually open and close, diverting the flow to the cutting tool or to recirculation. It's an important safety factor, and it's also important to get it's got to be suitable to take at least 3mm fines. And I've just been corrected by my colleague, Matt Benson. The RPX pipe is flush on the OD. Miguel Lopez says, aside of decoking directly in drums, you provide pigging systems, for example, for the furnace prior to the drums. We don't normally get involved in pigging systems. And in the delayed decoking system, the whole idea of injecting the steam is not to have coke forming in the pipes. The coke forms in the coke drum. Okay, I don't see any more questions at the moment. Oh, another one's just popping in. Here we go. Okay, and although my earlier answer on the ARC valve is correct, it is much harder for safety and there's no pre-fill, so it's not recommended, but an ARC valve can technically be used instead of the main control valve that we showed. Okay, we have no more. Yes, another question coming in. Stavros Kitsakis says, do you also supply the charge pump? Yes, absolutely. That if you do go look again at the schematic of the system, you'll have seen we can supply the charge pump to the furnace. We can also supply the water recirculation pump when the drainage from the coke drum, as we cut it, that goes back to a tank and is recirculated back around, and we can supply that. We supply that recirculation pump as well. Are there any more questions? No. Okay, well, if you do have more questions, you can send them to us through by email, info@shortcourses.com, shortcourses.ruhrpumpen.com, and they will be distributed to our experts to be able to give you the answers. All it remains for me to say is thank you again for attending today. I enjoyed preparing and presenting it. I hope you found it useful. So see you on the 27th of April for the next short course. Bye-bye.